Let's start the class. Right. So today is the second lesson, solid geometry, 3D geometry. In my last class, we were studying cylinders. Special cylinders are the rectangular box. Okay. So remember, a cylinder could be a circular cylinder, could be triangular cylinder, with triangular base, and any cylinder. By definition, a cylinder means you have two identical piece of a two-dimensional region and the parallel, then you connect them. Okay, this is the most general cylinder we can talk about. Okay, and this can be, it's not necessarily circular, just some section. So if the base area A is going to be the base area, and the height is this portion, this is the height, H is the height. Okay, then the volume is going to be A times H. That's it. So if you have a triangular a cylinder with a triangular base, and such as like this is a triangle, right? And then this is a, okay. So how do you find the volume? Well, the area of the triangle, here's the example. Let's look at the example. This is a equilateral triangle, just A and A and A, and this is H, right? How do you find the volume? Well, the area of the triangular equilateral triangle is going to be square root of 3/4A squared, right? That's area. So the volume is going to be A times H, okay, times this. Okay, so that is formula. Now today I'm talking about a cone-like solid. Okay, maybe call it cone-like solid. So cone could have a circular cone. It can be anything. Actually is just you collapse to one point. Okay, if you have a region in the plane. Okay, this is a region in the plane, and take an arbitrary point in the space. You connect them. Okay, so this will be a cone. So if A is a base area of the base, and this still you can talk about the height. This is a height. Okay, the volume of a cone will be similar to the volume of a cylinder, but this time it lost the volume of 2/3 of volume, so only 1/3 of the product. A times H is going to be the volume of the cylinder. Okay, then divide by 3. Okay. This is the base is this is a flat. Okay, this is a flat base. Okay, this is a flat base. Right? Yeah. Now, if it's not a flat base, okay, it's a little bit more general. If the base is a portion of the sphere, okay, if the portion of the sphere, let's call it sphere, right? This is just a portion of the sphere. Okay, this is A. Okay, then the point is a center of the sphere. Then you also get some kind of cone, but this looks like a spherical cone. Okay, so the radius is R. So you can view the radius as a height of the cone, right? Okay, but this is a spherical base. Okay, based on the sphere. If the area is going to be the surface area, right? Then imagine the volume is going to be 1/3 A times R. Okay. Whoa. Okay. Now the special case is this. Yeah, this can be a semi-sphere, right? Portion. The special case is the whole sphere. Okay. The whole sphere was reduced up, and the surface area is going to be 4 pi r squared, right? Do you remember, right? And then the volume is going to be 1/3 of A times R, which is 1/3 4 pi r squared times r, so that's r cubed. Right? Yeah. So now you understand why there's 1/3 for the volume divided by 3. Okay, and this can be the it looks like a cone. That's why I divide by 3. Right. So this can be a portion of the sphere. Okay. Surface, this surface, the base, could be a portion of the sphere. Okay. That's all about what we should know. Okay. And so let's do some exercise. Okay. I have a triangle. Okay. The triangle has 3 bases. It's a 5, 12, and 13, and have this is a cone over that. Okay. What I want to do, if I know the height, h is going to be 10. This is height. Okay. Let's try to find the area, the volume. The first thing we have to find is the area of the base, right? The area of the base. Yeah, find the volume. Okay. Okay. Now, so first of all, you have to find the area of the base, right? Right. So look at the triangle at the base. By the Pythagorean theory, okay, 5 squared plus 12 squared equals 13 squared. So it is a right triangle. So the base is a right triangle. Okay. so the area of the base is half of 5 times 12, which is going to be 30, right? Okay. So if it's a 30, then the volume is going to be 1/3 times A times H. So it's 1/3. So 1/3, and here 30 times 10. So it could be 100. Don't forget, yeah. Divide by 3. Yeah. Right. Yeah. Divide by 3. Now, so let's look at the box. Okay. So a cube. So look at the cube. This is a cube. Okay. This is a cube, and we can assume that it's 3 by 3 by 3 cube. Okay. What I'm going to do is I choose a point here. This is a point. Okay. So here's a 2. Here's a 1. Then I choose a point. Here's a 1. Here's a 2. And then I choose a point. Here's a 1. Here's 2. So different locations. Okay. So I cut the corner. Okay. So I want to find the volume. Okay, of this corner. Okay. Yeah, I cut through the corner. I want to find this. Okay, this is a volume. Okay, find the volume of this. Okay. All right, now this actually, you can view the cones in 2 different ways. Okay, and you can call this side the base, so it becomes a cone. Okay, so the A is going to be the area of this triangle, right? So it's 1, and here's 2. So the area of the triangle is going to be area of this triangle, right? So it's going to be 1/2 1 times, so that's just only 1, right? So the height, h, is going to be 2. So the volume is going to be 1/3 a times h. So 1/3 1 and the 2, so it's 2/3, right? It's 2/3, not the 4/3. Yeah, right? You just find out now. If you view, you can view any of this side, okay, right triangle as a base, right? How many faces of this this cone? You have 1, 2. You can also call it pyramid, okay? This has 4 faces, but there's one particular face is pretty strange, okay? And that was the triangle with all the 3 edges, right? So those edges could be square root of 5, square root of 5, you know, and this is going to be 1 and a square root of 5, and this side is this side is 2 square root of 2, and this is a square root of 5, okay? And there's a triangle with these 3 sides, because it's not easy to find the area, okay? Yeah. Okay, so let's take a look at this triangle. Okay, I put, actually we have and the square 5, square 5. Why square 5? Because square 5 is going to be square 2, square 2 square plus 1 square, which is square 5. Okay, the other side is 2 square root 2, because the other side is, each side is 2, right? 2 and 2, so that's 2 square root 2. Okay, yeah, this is a triangle 1 and 2, that's a square 5. Okay, so this is a triangle. My question is, what is the area? Do you still remember? What is the area of this triangle? Okay, can you find it? Okay. There are a couple ways to solve this. The best way to do is to find this one. Okay, let's call it h, its height. This is an isosceles triangle, right? So first of all, you have to write a triangle here, square 5, square 2, right? And this is x. So x squared plus 2 square 2 square equals square 5 square. So x squared plus 2 equals 5, x squared equals 3, x equals square 3. Okay, so the area is going to be 1/2 2 times square 2 times the height. So it's going to be square root of 6. Okay. All right. So my question is, if I draw a height to this, because above piece actually can be drawn in this form. This is a right angle, right? And I remember this is a square 5, square 5, right? And it's 2 square 2, so that's 2, 2, and this side is 1. See, and this is the one I just put it here, put on the top, right? I moved it to here, put on the table. Okay, so it consists 3 right triangles on the face, but the base is above triangle, right? So I can draw the height for this one. Yeah, what is the height? The altitude, yeah. This is the height, okay? attitude to of the point. Okay, if I call this is A, B, C, and D, you know, this is what is height of the point A, right? Above the triangle. Yeah, above the triangle. B, C, D. Okay, can you do that? If you know the three base, because okay, we use a volume to find out. Because first of all, the volume, okay, is going to be 1/3 times, okay, it's 1/3 times the base area, A times H. So I know the base area. I already find out the square root of 6, right? And the H is the height. But on the other hand, I already find the height. Find the volume. The volume of this, look at that, we already got it. It's 2/3. So you have a 2/3, right? Then. So then H is going to be 1/3 is gone. So it's going to be 2/6. Okay, so you can get all of the information you need there step by step. Okay, that's a good problem. Okay, our next problem is look at the cylinder. Okay, look at the cylinder. Okay, the circular cylinder. Okay, this cylinder, the radius is going to be 2. Here's the height is going to be 4. Okay, I have 2 points. It's opposite. Okay, this is on the diameter. Okay, this is point A. This is point B. We're trying to find out the shortest path on the surface, okay, from A to B. Okay, find the length of the shortest path on the cylinder from A to B. Okay. So if an ant want to go on the surface of cylinder from A to B, right, along which path it will take the least time. Now, to solve this problem, imagine you cut it open the cylinder. So depends on where you open it. Okay, if you cut here and you open and B becomes 2B is here and the A is here. It's in the middle. So as a path in general from A to B looks like that on the piece of paper, right? The shortest one. Okay, so this is H is going to be 4, right? H is 4. So that is a 4. Okay. Yeah. Other side is half of the circumference because the whole circle now cut, right? Open it. So it's 2 pi, because 2 pi r is 2, so 4 pi. So divide by 2. Okay. So imagine the shortest path must be straight line. So the answer will be, yeah, the length, okay, of the distance between A and B, the length of the shortest path is going to be square root of 2 pi square plus 4 pi square. Okay. Okay. And that's it. Now you have to use your imagination to do this problem. Our next problem, we're trying to compare. We have a cylinder. Okay, this cylinder, circular cylinder. Okay, and here's the ball. Okay. I know that this is R, this is H. I know I is going to be 1/4 of its height. Okay. And this is also the radius capital R. Okay. So if they have the same volume, okay, what is the ratio of R and little r over capital, the ratio of the radius? This cylinder, okay, this cylinder is completely determined by its radius, right? Because the height is proportional to the radius. So let's look at the volume of the cylinder. Let's like this. The volume of the cylinder is going to be like the base area pi r squared times h. H is 4 times r. H is 4 pi r then cube. Okay, because h is going to be 4r. The volume of the ball is going to be 4 pi capital R cube divided by 3. Right? Now, so that equal means 4 pi R cube equals 4 pi capital R cube divided by 3. So 4 pi will be cancelled out. And little r cube over little cube r, capital R, right? It's going to be 1/3. Now the question is, how can I express r over cube? So r over little r over capital R cube is going to be 1/3, right? So here's a notation. We express like in this form, okay? So let's recall, if x equals a, then we express x in this form, okay? Okay, so x cubed equals 7, that means x is going to be the third root of 7. So this is called the third root of 7. Okay, something like a square root, right, of third root of 7. This also denoted by the tradition denoted by it as is using this notation. Okay, now let's take a look at this cube. I have a cube. We have lots of things we can do, right? This cube, it's A and A cube. I choose the center of the top surface and I draw a pyramid. Okay. All right, so we want to do lots of things here. So first of all, what is the volume of, find the volume of the pyramid. Okay. Yeah, that's easy, right? Volume of the pyramid, it's easy. Okay. Okay. So the volume of the pyramid is the base area, right? The base area times height. The base area is a square. The height is also a, so it's 1/3 a cube. And so it takes 1/3 of the space of the cube, the pyramid. Okay, now what else we should know about the pyramid? Okay, so let's find out the ratio of the surface area of the pyramid to the area of the surface area cube. Yeah, we want to compare the surface area. Okay, I know the volume is easy to see, right? So the volume of the pyramid is 1/3 of the volume of the cube. Okay. Okay. Now the challenge is, yeah. So you got a volume, right? For that. Okay. So the volume of the cube, right, is going to be a cube, no problem, right? But the surface area of the cube is 6a squared, okay? So I know the volume of the pyramid, right, is going to be 1/3 of a cube. So the ratio is clear. So how can I find the surface area of the pyramid? The surface area of the pyramid, including the base, okay? So this is something like that, right? So it consists of 4 identical triangles on the top. So each triangle, now this is very challenging, right? How can I find the area of the triangle, right? The triangle, I needed to find this height, right? I needed to find this height. That's okay, each triangle is an isosceles triangle, so I draw the point from here to here. So what I got is I got a right triangle. So sometimes we have to draw a right triangle vertically sitting in the space. So what is that one side? The one side is A. This side will be, because in the middle, just half of A. Okay, it's a half of A. All right, so half of A. And so by the Pythagorean theory, right? So A squared plus half of A squared equals H squared. So that is going to be 1/4 plus 1. So 5/4 A squared equals H squared, right? Yeah, so H is going to be square 5/2 A. So you find the height. So now the triangle of each isosceles, the area of each isosceles triangle will be the area of this one, okay, is going to be, right, is going to be the base times the height, okay, so which is going to be 1/2 of A, square 5/2 A, okay, so it's a square 5/4 A squared. So total surface area, okay, of this pyramid, including the base, okay, at the bottom is going to be the base is A squared. Then you have 4 triangles, right? So add them together, you get A squared plus a square 5A squared, right? You can take A squared out. So that is, then the ratio, what do we find out? Just find the ratio, right? The ratio of surface area pyramid, okay, the ratio surface of a pyramid and over the area of the surface area of the cube. So that would be 6 A squared. And then cancel, and that is the answer. Okay, so that would be the answer. Okay. So the difficult part is to find the height of the triangle, altitude of the triangle right. So there are another type we have to we can look at is this is a pyramid again. Okay, and then it's a right pyramid. Okay, so this side, this time, I know all the triangles are the same size, equal rate triangle. So can we find the volume of this pyramid? Okay. Well, if you want to find the volume of this pyramid, what do you have to do? You just need to find the, if you draw the height, right? You have to find the height, h. Okay, so what is the best way to find height? There are a couple ways to do. One is you still use this triangle. Okay, use this triangle and apply the Pythagorean theory to find height. Then you have to find out, the height of the triangle on the side, triangular face, right? And this bottom is half of it, right? Because of center. That takes 2 steps. You have to find the x step by step, right? That's not too bad because when you look at the triangle here, here's A, here's A, here's A, and this is a x, right? And what is x? X is going to be square root of 2a. I think we already know that. But if you did a lot of exercise, you already know that. It's just applying the Pythagorean theory to that triangle. So then h squared plus half of a squared equals x squared. So you get h squared, okay? So h squared is a squared over 4. X squared is going to be 3 over 4 a squared, okay? So you do subtraction. So it's 1/2 of a squared. So you find out h. Okay. So this is AIH. Then the volume is going to be 1/3. And the base area times h. The base area is a square. H is going to square root. Okay. You can simplify a little bit, and it's going to square 2 over 2 and a cube. Okay, so that's the answer. All right, our next problem is about the cube. Inside the cube, there is a ball in square. That means it touches all the faces here. Okay. So a ball is inscribed in a cube. Okay, that means touch all the faces. If the volume of the ball, you know that is 12 pi cubic meters. What is the volume of the cube? Okay, please do this problem. Okay. Anyone have answers now to this problem? I just want to find the volume of the cube. Okay, not a ring. Okay. Okay, so this side is A, this side is A. It's a radius R, right? Clearly, R is going to be half of A, or A equals double the radius. Got it? So you all have to know is about the radius. Okay, then you know the height. So the volume, okay, of the ball is going to be 12 pi. But that is going to be 4 pi over 3 R cubed. Right? So let's figure it out. So R cubed, okay, is going to be R cubed, pi cancelled out, right? And actually it's going to be 3 squared. Wow. R cubed is 3 squared. Can I find R? I probably don't want to find R, okay? Because if you really want to find R, it's going to be 3 squared to the 1/3, or it's 9 to the 1/3, okay? But we don't need it to do that, okay? What I need is the volume of the cube. The volume of cube is A cubed, so it's 2R cubed. All I need is, this is 8R cubed. I need the value of R cubed. So it's 8 times, R cubed is 9, so it's 72. Yeah, 72 cubic feet. Right. Let's go back to the problem again. We did it before, a similar one, okay? This is the right pyramid, okay? This time, I have a 10, and that'll be 13 and 13. All the sides are 13. The base is 10, 10, 10, okay? Find the volume of this pyramid. This is the right pyramid, the regular pyramid, yeah. Of the right pyramid, okay? So the center is right above, the vertex is right above the center of the square. Okay, so yeah, can you work out this problem? Okay. So all you need to find the height, right, of the pyramid. Right? How do you find the height? We did it several times, right? So you draw the line to here, and you draw another called the lateral attitude, right? So you take a look at this lateral attitude. Here's a 10, here's 13, here's 13. So that will be called X, right? So that will be X here. And you look at the picture, this is basically triangle, right? So this side is 5, this side is 5. So X must be square root of 13 square minus 5 square is 12. So you get 12. Then you go to the triangle in the space. Here's the X is 12. Here's the H. This is still 5, right? Okay, right? So H squared plus 5 squared equals 12 squared. So H squared equals 144 minus 25. And that is going to be 119, right? That's 119. Yeah, 119. So H is a square root of 119. 119 is is a prime number. Yeah. So the volume is going to be 1/3 times the base area times height. So it's 1/3 the base area is 10 squared. The height is 1 square root of 119. Okay, so that is answer. Got it? All right, so we're always talking about square based. Okay, this time I'm talking about equal. The pyramid is consists of all equal triangles. Okay, so they're equal triangles. Okay, just like that. Okay, all faces are equilateral triangles with edge length of 8. Okay, and what is the volume? Wow. Equilateral triangle. Okay. So I can use the same idea. Draw the height h, and then you can. I think you can go this way. Yeah, you go this way. Okay. So you get to write a triangle like this. As this side is 8. Okay. You have to find out the height. Okay. The height, if you know this side is x, then you know the height, right? So let's take a look at the triangle here. And where's x? X is going like this. This is the center. This is my x, right? So this is my x. This is my x. And how find the x? Can we do that? How to find x? Once you find x, you can find h. Once you find h, you can find the volume. Okay? So step by step, are we able to find x? How do you do that? Okay, how do we do that? Well, we can extend it. You get to write a triangle. Okay, and this is half of a. So this will be actually half of x. Okay, then using the Pythagorean theory, right? So actually, half of a should be equal to square root 3 over 2x. Okay, because it's a 30 degree, so it's a ratio. Okay, and yeah, right. So from here you can get 1 over square root 3a. Right, so that is x. You find x, then you apply the above formula, h squared plus x squared. You know, you look at this triangle, right? And here's X, here's H, here's A. You know, this is a triangle we're talking about, the yellow one. It's colored. Okay. So that is a yellow triangle. Okay. Yeah. We are identical. This is a triangle here. It's a triangle here. Okay. So this yellow triangle is A squared and H squared plus. So H squared is A squared minus 1/3. A squared is 2/3 A squared. Okay. So H is going to be square root 2/3 before I simply just put this. All right, so that's it. And you find the H, then you go back to the go back to triangle, pyramid with the base triangle. So the volume is going to be 1/3 of A times H. What is A? A is the base area, which is a equilateral triangle. So it's a, we already know that, that's A. H, we already find out, that is H, okay? So square root 3 cancel out. And I have a square root 2 left on the top, and that is our answer. Okay, that is our answer. Yeah, so you have to use a right triangle to find the height. Okay, you have to use a right triangle to find height. Okay, let's go over this problem again. Oh, what's going on? Let's go over this problem again. Okay. All right, so you have a pyramid with triangular base, and you get equilateral triangle on the base. So you know the area of the base, right? So the base area is going to be square root 3/4 A squared. So that's for the area of the base. All you needed to do is find the H, right? Have to find the H. In order to find the H, you have to draw the right triangle. Then you find out you need to find another H, the length of another H. But that, then you have to work on this two-dimensional problem. Okay? So you have to work on this two-dimensional problem. Okay, then you draw another right triangle, then you apply the Pythagorean theory, you figure out the H. Okay, so so you have to use the Pythagorean theory to find the H. Okay, that's important to draw addition lines to get the right triangle. Okay, then you solve the problem. So we did several problems like that. Okay, and so our next problem will be a cube is inscribed in a ball with radius r. Okay, a cube is inscribed in a ball with radius r. Okay. Express the volume of the cube in terms of r. What is the volume of the cube? Okay. Inscribed in a ball means this is the largest possible cube. Okay, the vertex touch the surface, touch the sphere. Touch the sphere, all the vertices touch the sphere. So all you needed to do is all you needed to do is to all you need to do is to find the edge length of the cube, right? Okay, have to find the edge length of the cube. All right. No, don't ask that. Okay, please focus on the problem. You're not able to do it right now. Okay, don't draw it on my screen. Okay. All right. So can you find the edge length of the cube? Right. Right. Anyone? Come on. Please do that. Okay. The edge length of the cube expressed in terms of radius r. So that's the A, right? That's A and the A. A. Right. You see, the diagonal of the cube is the diameter of the sphere. So this will be actually 2r. Do you agree? Then you're done. Okay. So 2r squared equals a squared plus a squared equals a squared, you know. So actually 2r is going to be square root of 3a. You know, we know that the length of the diagonal of the cube is going to be square root 3 times a. Okay. So r is going to be square root 3 over 2a. That is okay. Or a is going to be 2 over square root 3 and r. Okay. So the volume of the cube is just a cube. Okay. So all I have to do is just cube it. Come on, 3 over 3, right? Now, how do we simplify this number? The top one will be 8, right? 2 cubed is 8. How do you do this? Well, the denominator here's 8, so this can be square 3 square and the scale square 3, right? I can rationalize the denominator. I put square 3 in numerator and denominator. So I can simplify. Here's 8. So here 3 is 9. That is the best form we can have. Okay. All right, so now let's look at the last problem. It's going to be a challenger problem. Okay. So a sphere is inscribed in the circular cone of the radius 3 and height is 4. So this is a circular cone. Okay, radius equals 3. Okay, the height h is going to be 4. I have a ball inside. Okay. So this ball is inscribed in the I want to find the radius of the sphere. Right. Right, please, I'll give you 2 minutes, okay? Work on this. Okay, how do you do that? Anyone have answers? Have to draw the picture, right? Figure out the radius. Okay, let's use a capital for the base, the radius of a circle. Yeah, my hint is I cut the cone into equal part. I get the cross section is a triangle. So then the ball becomes a sphere, as a circle inscribed here. Okay, right? So I want to find the radius. Yeah, find the radius. Okay, what do we are given here? Any idea? You see, if you have a triangle, you're trying to figure out radius, right? Draw the addition lines to connect the important points. Okay, so you will, yeah, you draw the line, right? So there are many lines, right? Connected. Okay. So there are a couple ways to solve this problem. I can use, okay, if this side is 3, right? This side is 4. That side is 5. Okay, got it? So I can find the radius in 2 different ways. I connect all the lines. So the area of the triangle is going to be half of 6 times 4. Okay, it's 12. But this consists of the 3 triangles was all the bases. Half of the 3 triangles, right? So 3 triangles, I can color it. One is this one. Other one is this. Okay, and then the third one, I don't want to color it. So the base here is going to be 6 times r. R is the height of the triangle, half of 5 times r, and half of 5 times r. So if I add them together, it'd be 16, right? R, so it's 8r. So r is going to be 12 of 8, which is 4 of 3 over 4, or 3 over 2, yes. Okay, so that is one way to do. Okay, another way you can do is, let's go look at it. This is actually a 2-dimensional problem. Okay, because it's an isosceles triangle. Okay, so how can I do that? I draw the line and I draw the this one. Okay. Okay, this is radius r, right? And here's the 3, right? And these 2 triangles are congruent. Okay, these 2 triangles are congruent. Okay, so if this side is 2 other side, because these 2 angles are the same. Here's the radius r, right? So those 2 triangles are congruent. Let me color it. Those 2 triangles are congruent. Yeah, these triangles, the other triangles, are the same. They're identical. Okay, therefore, why are they identical? Right, they have the 2 sides are equal and then the right angle, right? And so this side must be 3, and then this side must be 2. All right, let's continue to get more information. And how about this side? We already know the total height is a 4, right? So this side is a 4 minus r, right? So now you get a triangle, right? A triangle. This is a 2. This is r. Here is a 4 minus r. So applying the Pythagorean theory to this triangle. So r squared plus 2 squared equals 4 minus r squared. Let's expand it. 4 minus I is 16 minus eta plus r squared. R squared is cancelled out. So eta equals 16 minus 4 is 12. So I is going to be 12 over 8. That is 3 over 2. So you get 3 over 2 again. Okay, 3 over 2 again. So different method leads to the same solution, same answer. Okay, and those two methods you should know.